Okay, so theoretical versus experimental probability. Okay, so theoretical, guys, this is what should happen in an experiment. Does that mean it's what always happens? No, but this is what you would expect to happen. For instance, if I have a coin and I flip it, what's the probability I'll get a heads? What's the probability I'll get a tails? So if I flip a coin, say the first time I get heads, am I going to get tails the second time? Not necessarily, right? Because that's not how it works. But theoretically, that's how it should work, right, guys? Does that make sense? So then experimental probability is what actually happens in an experiment of many trials. So theoretical is what should happen. Experimental is what actually happens. Does that make sense? Okay. So we're going to do kind of a little activity with rock, paper, scissors. Okay, so first of all, we need to figure out the theoretical probability of rock, paper, scissors. So we need to fill out this table. I've got player A, I've got player B. If player A gives rock and player B gives rock, what happens? So we're going to write a T in that spot for a tie. If player A does paper and player B does rock, who wins? If player A does scissors and player B does rock, who wins? I want you and your partner filling out the rest of that table, please. Go. All right, help me out. Second row. Who wins? Then who? Then who? Bottom row, who wins? Questions on that at all? Now that is theoretical. That's what should happen. Okay, so if I come down here to number 1, it says, what's the probability of player A winning? Well, how many times does player A win?
3.
Out of how many total?
9.
So the probability that player A will win is 3/9. And what do I have to do with every fraction? Simplify. It's 3/9. 3/9 simplifies down to?
1/3.
This should be memorized. This is one of those fractions you should know off the top of your head. What's 1/3 as a percentage? 33.3%. That needs to be memorized, guys. You have to have the simple ones memorized. 2. What's the probability that player B will win? Which equals? Which equals? What's the probability it will be a tie? And 3/9 equals? Which equals? So there is the same probability that player A will win, player B will win, or it'll end in a tie. We have the same probability across the board theoretically. Does that make sense, guys? Questions? All right, yes, sir. Typically, yes, it has to equal 100. But because this is one of the repeating decimals that goes on forever and ever and ever, when you add it all up, it'll equal 99.99999, which if you round it equals 100. So it's just kind of one of those weird ones. Okay, so now you and your partner are going to do your experiment. You are going to play rock, paper, scissors 25 times, and you are going to give a tally mark for who wins. So I don't care which one of you is A, I don't care which one of you is B, but do your tally marks. 25, 25 only. Go. All right, so when you're done,
yours is obviously going to have your own numbers. So you'll have your own tally marks and your own totals. If you don't have your totals, make sure the totals are there and that it adds up to 25. Is that clear? Okay. Hopefully no one's working ahead of me. Okay, because you got to stay with me. Okay. So now I want to figure out what's the probability that player A is going to win based on our experiment. Because experimental probability is based on the experiment. So for me, player A, how many times did player A win?
6.
Out of how many total? Now remember, all fractions must be in simplest form. For me, that's fully simplified. And then I need to turn 6/25 into a percent. Once again, you can do 6 divided by 25, but 25 is one of those numbers that goes into what? So what could I do instead? Times 6 by 4. And what's 6 times 4?
24.
So partner A, my person A, got it 6 out of 25 times, and that equals 24%. Does that make sense, everyone? You and your partner need to do A, B, or 4, 5, and 6. Finish that out with your experiment, not mine, yours. Is that understood? Go. So this is mine. I have 6/25 is 24%, 11/25 is 44%, and then 8/25 is 32%. Yours should all be based on yours. Is that understood? Next thing you do is once you know the theoretical and you know the experimental based on whatever they're talking about, you can compare the two. So I look at 24% and 33%. Is my experimental probability greater than, less than, or equal to my experimental? So I would say it's less than. You would say whatever yours is. Is yours greater than, less than, or equal to? Then I would do the same thing for B. Is my B greater than, less than, or equal to? So I would write greater than. Once again, you do whatever yours is. And then the last one is mine greater than, less than, or equal to. So do you see how we do the theoretical, the experimental, and then you compare them?
Yeah.
Questions on that at all? Question number 7. Do our theoretical results match our experimental results, you guys? Not really, do they? It's because your experimental is an experiment. It's a chance, a game of chance. That's all probability. So how could we get these experimental results to be closer to the theoretical? What could we do to get them closer? What do you think, Eva?
If everybody chose rock, paper, scissors in a pattern.
Okay. But we can't force that, right? So what could we force to do?
Play 9 games.
Could, but that wouldn't necessarily do much.
Like limit how many times you can do each.
Yeah, but you can't control that. It's got to be something you can control. Remember when you guys do science experiments in science class, you have to be able to control it. What is something we can control? And it's closest to what Bennett said. He just was on the off side of it. What do you think, Sophie?
I was just going to say, it's 11.
What do you think, guys? What do you think, Gabriel?
Try to control how many times you win.
Say that again.
Try to control how many times you win.
Okay, I wish we could, right?
Yeah.
So it has to do with the trials, as Bennett was saying. But it's not based on 9 trials. The more trials you do, the closer you get to the theoretical. The more the experiment is done, the closer you get to this theoretical. Because you're doing it more. Okay? So what you do is you run more trials. Then I'm going to put a lot more. I mean, like, if you were to run like 1,000+ games of rock, paper, scissors and keep track of it, you would be closer to the theoretical. The more the experiment is done, the closer you get to that theoretical. Does that make sense, guys? Do I have any questions on that? Okay, let's go to the next page, which is pink. Okay, 9 and 10 kind of go together. And this is what your homework assignment's going to look like. You're going to see question 1, question 2, and it's going to be kind of put together, and I'll explain your homework when we get to it, okay? But question 9 has problem A and problem B that goes with it. Letter A says, what is the theoretical probability of rolling a 4? Is theoretical probability based off of this table? No. This is my what? This is my experiment. So do not confuse the theoretical with the experiment. The theoretical is based off whatever object you're using. In this case, I'm using a dice. So if I had a dice in my hand, what's the probability that I'm going to roll a 4? 1 out of 6. Because it's based on the dice itself, not on you performing an experiment. Does that make sense, guys?
Yeah.
Then letter B says, what's the experimental probability of rolling a 4? That's based on your table. So what's my experimental probability of rolling a 4? 5 out of 50. Because we rolled the dice 50 times and we rolled a 4 5 times out of 50. Simplified down, because I have to simplify everything, equals what? And we need to turn all fractions into what? Percents. So grab your calculator, do the 1/6 in your calculator, round to the nearest tenth for me, so one place after the decimal. Hopefully 1/10 you guys don't need a calculator for. One-sixth, guys. What's the percentage? 16.7. You have to round. Make sure you round properly. And what's 1/10? Okay, so when it says compare this to the theoretical probability, is 10% greater than, less than, or equal to the theoretical? So you would tell me less than. That's essentially what you're doing on your homework. The way the problem's set up just looks different, okay? And I'll show you that when we get to it.
Is that the only thing we need to use? The less than greater than?
Yep. Yep. You can use other words that mean that, but those are just the easiest because we're used to using them. Okay, do number 10 with your partner. And we'll go over it in a minute. Go. Okay, back up front. Number 10. We use this spinner. These are the results. We did it 75 times. I want to know the theoretical probability of spinning a shaded letter. What do we get, everyone? Why was it 3/4? Good. It was originally 6/8. That simplifies down to 3/4. That percent should be memorized, which is
75%.
questions on the theoretical. Okay, now based on the experiment, what's my original experimental probability? 60 over 75. And then when I simplify that down, that equals what? 4/5. 12/15 can still be simplified. And 4/5 equals what as a percentage?
80%.
So those two, you didn't even need your calculator on, and then you have to tell me, when it says compare to the theoretical, is 80% greater than, less than, or equal to? So you would tell me it's greater than. Any questions on finding the theoretical, the experimental, and comparing the two? All right, the bottom is where we now have to use samples to predict what we would get. Okay, so here's what I mean by that. Once again, theoretically, so it's based on theory, how many heads would you expect to occur out of 300 tosses? Now, I know that this one's easy, but I need to show you how to set it up so you understand it for the future. Got it? Okay, because they won't all be this simple off the top of your head, okay? Theoretically, guys, what is the fraction that I would use to get a heads? So theoretically, we would get a heads 1/2 of the time. Is that understood? That is then equal to the ratio of what you would expect to get of how many heads out of 300. Do we know how many heads we will get out of 300? No. So if we don't know, what do we put there? You put a variable. You put an X, right? I don't know how many heads that I will get out of 300 total. So I have 1/2 equals X over 300. This is a proportion. Do we remember how to solve proportions? What do? Cross multiply. Good. What do I cross multiply? What's 300 times 1? And that's equal to what? So 300 equals 2x, and then what do? And what's 300 divided by 2? So we would expect to get heads 150 times. Now I know that one you could have done without that, but does that make sense how you would set it up for all of them that are not that easy? Okay, so letter B, we're doing the same thing, but this time it's based off the what? Experiment. So what is the experimental probability that I will get a heads? 58 out of 100. Because I got heads 58 times out of 100 total. That's my experimental probability for getting heads. Does that make sense, guys? That's then equal to what? X over 300, because I want to know the experimental probability of getting heads out of 300. So these two proportions were set up exactly the same. The only thing that changed is one of them I had a fraction for theoretical, and one of them I had my fraction for my experiment. What do I do now? Cross multiply. What's 58 times 300? And that's equal to? And what do we do now? So X equals what? So in our experiment, if we did it 300 times, based on the results we have, we would expect to get heads 174 times out of 300. Questions? Isabel?
Could you just multiply the 58 times 100? I mean, times 3?
Yes. But once again, that's not always going to work. So, whichever way is totally fine as long as it works properly based on any of the methods I've taught you. Do number 12, A and B, with your partner. We'll go over it in a second. Go. Alrighty, here we go. So, theoretically, guys, if a letter was chosen at random, how many vowels would we expect theoretically? Don't give me the answer. I want to go through the whole thing. So, theoretically, what was be the probability? Oh, pen. There we go. Okay. So theoretically, we would expect to get a vowel 2 out of 7 times. Yes, guys? That's equal to what? X over 500, because we don't know how many times out of 500 that we would get a vowel. What do we do now? Cross multiply. What do we get? 1,000 equals 7x, right?
Yep.
Now what? So what would we get if we rounded to the nearest tenth, you guys? So roughly 143 is how many times we would expect to get a vowel. Does that make sense? Okay. Experimentally, what would my probability be? 24 over 80, and that's equal to? What do we do now? What's 500 times 24? And that's equal to? And what do we do now? So 12,000 divided by 80 is? So we, in our experiment, got a vowel 150 times. Does that make sense? Morgan.
So how did you get the 2 sevens for A?
Because there are 2 vowels out of 7 letters.
Okay.
Because it's based on the theoretical. So you can't look at the frequency, because the frequency is the experiment. The result is the what you have on whatever they're asking you for. Does that make sense? Braden.
So theoretically, has nothing to do with the numbers, like, at all, like, how many times it happens?
Yep. Correct.
It's just based off, like, the ratio, is it?
Yep.
Okay.
Yes. That is the tricky part with it, because a lot of people want to use the frequencies, and that only matters for the experiment. Does that make sense, guys? Okay, let's go explain your homework assignment. You guys know how to do it all. I taught it all to you, but sometimes students look at this and get a little confused just because it's set up differently than their notes were. Okay, first of all, cross off the word decimal. Remember, I just want simplified fractions and percents in my answer. Don't need that decimal at all. So the way that this works is questions 1, 2, 3, and 4 all go together. Okay? Question 1 is the theoretical. So A, B, and C, you're answering the theoretical for the spinner on number 1. Does that make sense? Question 2 gives you the table for the experiment of the spinner in number 1. Does that make sense? So then A, B, and C on number 2, you're answering the experimental that you see right next to it. Is that clear? Then notice you need to compare to the theoretical. So once you get your percent of A, you are going to compare letter A to letter A. Is it greater than, less than, or equal to? You'll compare B to B, C to C. Does that make sense, you guys? Then 3 and 4 are the theoretical and the experimental of the problems just like we just solved in our notebook with proportions. But they go to 1 and 2. Does that make sense, guys? Do I have questions on that at all? Okay, then question 5 is a new theoretical problem based on this spinner. So you answer A, B, and C. Then you go to page 13. And question 6 is the experiment results of number 5. You'll answer A, B, and C, and then once again you compare. Is it greater than, less than, or equal to? Then 7 and 8 are the proportion setup problems for questions 5 and 6. Are you guys seeing how this pattern's working? Because then questions 9, 10, 11, and 12 are exactly the same. It just starts over with a different problem. Don't forget you need to compare greater than, less than, or equal to. I need fractions in simplest form. I need percentages. The ones where they're asking you for the expect, those are the proportion ones with just an answer. Questions on pages 12 through 13. Where do you need to turn this in at? Please turn it into Google Classroom, but you will have to show the sub tomorrow. Or me, I guess if I'm here too, you still have to show me it tomorrow. Does that make sense, guys? Questions? Yes, Brayden.
There's what number you want us to round to if we have to round.
I think most of my answers go to the nearest hundredth.
Okay.
on my sheet. But as long as you round properly, I wouldn't count it wrong because the directions don't specifically tell you where to round to.
Okay.
Other questions, you guys? Okay. Use your time wisely.